Hello, I welcome you all in this presentation related with the subject fundamentals of the manufacturing processes, and we are talking about the metal joining processes. And among the metal joining processes, like in the last presentation I have talked about the fusion based welding processes, and we will see now the brazing, soldering processes, and maybe adhesive joining also. We will try to talk little bit about the adhesive joining processes. Brazing and soldering processes are called liquid solid processes because the joints to be made here between the base metals remains in the solid state, while the filler metal is brought to the molten state between the at the fin surfaces between the joint. So, liquid is the filler metal and the base metal remains in the solid state. This kind of the processes needs very less heat input and gives the joint, now strength of the joint is somewhat less or it is poorer than the base metal, but still it is good for working in number of situations and number of conditions where high strength, high load carrying capacity is not a major requirement. For example, like developing the solder joints where electrical connectivity is more important. Similarly, brazing joints where compressive forces are acting like in cutting tools. So, the stress and strength requirements are not much high. So, under those conditions, the brazing and soldering is found to be very effective. There is another process which is called adhesive joining, where in the chemical reactions between the adhesives and the functional surfaces, the fin surfaces of the joints to be made in. So, adhesive is placed in that case. Normally structural adhesives are used for high strength joints, but these cannot be used for the high temperature conditions and even for the external environmental conditions, because these under these two conditions the adhesive tend to degrade and the joint is weakened very badly. So, the conditions under which the brazing joints and soldering joints are preferred include like where the fusion welding is not possible due to the poor weldability. Due to the poor weldability, the fusion welding is not a workable option. The second is completely different metals like dissimilar metal systems need to be welded where the compatibility between the two does not exist. For example, like there may be iron based alloys and aluminum, or iron and copper, titanium and steel. So, these are the systems which are, if they are not metallurgically compatible due to the variety of regions like difference in melting point, expansion coefficient, yield strength. So, they create lot of problem during the fusion welding. That is why dissimilar metal joining can be facilitated in a number of cases through such kind of the joining processes where the base metal remains in the solid state, only the filler metal is brought to the melting point. And then we have the conditions like the heat affected zone. We have seen in the fusion welding processes application of heat results in the fusion zone, but nearby a lot of heat affected zone is formed which has different properties in terms of the metallurgical characteristics and the mechanical behavior. Even the corrosion properties are adversely affected. So, if the heat affected zone is unfavorable which is produced in the fusion welding, so avoiding the heat affected zone, avoiding HAZ helps when the brazing and soldering processes are used, and like even the low strength joint is okay, and the conventional welding processes are not applicable as per the accessibility. So, processes with regard to the accessibility and the workability of the joining. So, these are some of the conditions wherein it does not work where the conventional welding process are not working, and like very thin sections and thin sheets need to be welded, there the brazing and soldering can be effectively applied for developing the joint, while the fusion welding may not be feasible and workable effectively. So, to deal with these conditions, the brazing and solder joints are used. Now we will see the basic principle which is used in these processes in the development of the joints. So we will take up first the brazing joints. For this purpose, like say the plates to be welded are mostly there can be the different kind of arrangements wherein like lap joint or the butt joint both can be made, but it is more common to use the lap joint configurations for the brazing purpose. And whatever like say this is the butt joint configuration, and the different joint designs have been proposed for the butt joint configuration. Here this is the square one, but a square one will be okay if if the strength is not a major criteria, because the weld area is very limited. So in order to increase the strength of the joint, in this case some kind of the joint is prepared in such a way that the joint area is more, so such a larger joint area will be increasing the strength of the joint by making the fixing surfaces at certain angle. Another arrangement which can be made is like this for developing the butt joint, like this. So this is also butt joint and the fixing surfaces, and in between the fixing surfaces the brazing joint, the brazing alloy is applied. Then there is another kind of arrangement where near the fixing surfaces the cross section is increased. Like this, so that larger joint area can be achieved for having the desired strength. And here this is the location where brazing system will be applied. So increasing the strength in all these designs is based on increasing the joint area for the brazing purpose. So for brazing, basically the brazing alloys are used for brazing purpose. They normally have the melting point greater than 450 degrees centigrade, but the issue with this is that the brazing joint generally they have like the temperature in the range of 450 to like say 800 to 900 degrees centigrade in terms of the melting point. So if we compare, like if these are being used for joining of the steels, then strength of the brazing joint is lower. Their ability for the high temperature withstanding is lower. They cannot withstand at high temperature, as well as they sometimes because the brazing material is different from the parent material, so galvanic corrosion is proposed. Galvanic corrosion is promoted by this, and even color mismatch is also observed when the brazing is performed. So these are some negative aspects apart from the benefits which are produced, like the joint is made with a reasonable strength without melting of the base metal, limited heat input, limited size of the heat affected zone. So there are so many beneficial aspects related with the brazing. For brazing, a special kind of approach is used wherein the surfaces to be joined are cleaned properly and they are smoothened properly, so that the flow of the metal can be smooth. Like say in this configuration, this is the lap joint configuration, and various lap joint configurations are used here. One typical one is this one, wherein the surfaces to be joined are placed in overlapping position. Another one is maybe like this, wherein the components to be joined are kept in overlapping position this manner, and here this is the overlap portion, and then there may be an arrangement wherein the plates are kept both the sides in this way, and the brazing joint is made like this, and then a sleeve can also be used in this manner, where the like say the rods to be joined in this manner. So, brazing LY will be placed here, and then sleeve on both the sides is applied in this manner, and here all this area is brazed. So, for brazing purpose, the important thing is surface cleaning. Surface must be clean from the dust, dirt, grease, oil, paint, etc., because these are the impurities which will be hindering the flow of the molten brazing LY. And apart from this, the surface must be smooth enough, because the molten metal has to flow through under the capillary effect between the fin surfaces in order to get uniformly distributed. And so the smoothness and the cleanliness is important. Thereafter, it needs to be heated to the proper temperature, so they can reach to the melting point. So, what we do basically say, this is the kind of arrangement which is to be brazed. So, here the plates to be brazed will be heated, the cleaned and smoothened surfaces will be heated, and then maybe flux is applied, which will help in improving the removing the oxides and facilitating the wetting of the brazing material. And then brazing material is applied here like this, so it melts, and due to the and then it flow it by the capillary action, it is sucked inside and gets uniformly distributed. So, for having this capillary effect, what is important, that the gap between the two is very closely maintained, 0.0125 to 0.125 mm kind of the gap is maintained, and this will be depend upon the metal of the brazing LY, the kind of the surface conditions which exist at the surfaces, and the cleanliness. So, since the flow is here by the capillary action or distribution of the molten brazing metal between the fin surfaces by the capillary action, so cleanliness, smoothness, and proper fluidity and wetting of the surface by the brazing material is important, and flux to some extent helps in removing the oxides and improving the fluidity of the brazing material, so that it can spread uniformly between the fin surfaces in order to form the joint. And after the solidification, the joint is produced. The common kind of the brazing materials which are used brazing alloys are like copper, zinc, copper, tin, then copper, phosphorus, and the nickel based alloys are used as a brazing material. Compared to the shoulder joints, the brazing joints offer much better strength as compared to the shoulder joints, because the shoulder joints use the filler metals having the melting point less than the 450 degree centigrade. So, next is the shouldering. So, shouldering basically uses the shoulder for the joining purpose. The principle of this is same as that of the brazing, but it is of the much weaker, much lower strength, and melts at much lower temperature. For the soldering purpose, various kind of the shoulders are used, like lead, silver, lead, tin, tin antimony, tin silver, tin zinc. These are some of the soldering systems which are used, and most of these will be melting at the temperature below the 450 degree centigrade for the soldering purpose. Because of the lower melting point, they offer the somewhat lower strength, and the limited capability to withstand at high temperature. So, they are good for the low temperature conditions. So, these are low in strength and lower capability to withstand at a high temperature. Just like in brazing, uh, surface preparation in terms of the cleanliness of the fin surfaces and the smoothness is important, and the gap needs to be controlled very closely, and for this purpose the gap between the two is controlled in the range of like say 0.075 to 0.125 mm, and again this gap will depend upon the kind of shoulder which is to be used and the surface conditions to be used. So, obviously very low heat input is needed for melting the low temperature melting point shoulders. So, this kind of heat can be like shouldering iron can be used for, but likewise there are number of methods through which heat can be applied for facilitating the melting of the shoulder at the fin surfaces. So, through the capillary action it gets distributed uniformly across the in the gap between the surfaces to be joined, so that the joint can be made to improve the wettability. And normally the zinc and ammonium chloride is commonly used. Flux borax is another one which is used, but these needs to be cleaned properly so that and any kind of the corrosion effect on the joint performance can be avoided, because the residual fluxes can be harmful from the corrosion point of view of the base metal. Now, coming to the adhesive joints. Adhesive joint is the kind of the involves the chemical bonding, wherein like the plates to be joined are kept in normally in the lap joint configuration, but these can also be used in other joint configurations as well. Say for example, the kind of joint configurations for this one for the adhesive joints are also similar to that of the which were used for butt joint configurations, like adhesives placed in this manner by making for increasing the joint surface area in butt joint configuration. Similarly, that has another joint configuration is like this, and here the adhesive will be placed. This is the kind of component. So, adhesive will be placed all around this surface area. So, these are the methods which are used for increasing the area of the joint. Like another one is like this, the component, and another component having the configurations like this, and entire this area is applied with the adhesives. So, this increased joint area will be leading to the increased joint strength in the butt joint configuration. Likewise, the number of other kind of the joint configurations are there which can be used for increasing the joint surface area, but it is more commonly used for the lap joint configuration, which is more simple like this. The components to be joined are called adherend, and the adhesive which is applied between the fin surfaces is called adhesive, or the filler which is applied is called adhesive. Mostly this is structural adhesives for increasing the strength of the joint, and basically the chemical reactions between the adhesive and the surface, and the physical reactions and the mechanical interlocking. These are the three mechanisms. Mechanical interlocking, these are three mechanisms which will be increasing the which will be responsible for the joint strength. So, some of these like the chemical and the physical reactions which will be occurring after the solidification, after the hardening of the joint, and for this purpose normally the curing is performed at a controlled temperature, and the time, both these play an important role in ensuring the desired strength of the joint. So, adhesive joints are cured properly in order to have the reactions like during the curing. Actually, curing increases the strength through the polymerization. This is one, vulcanization and condensation. And condensation. So, these things will be happening during the curing, and it's important that curing is done under very controlled conditions of the temperature. Normally, like 100 to 150 degree centigrade temperature is used, and curing should be done for optimum duration, because otherwise it will lead to the under curing or over curing. In either case, the strength of the joint will be less. So, in case of under curing, when the curing has not been done up to for a proper time, then it will lead to the limited reactions which will be occurring during the curing, and over curing can lead to the thermal degradation of the adhesives due to the exposure at a longer period. So, over curing can also be harmful for the joint strength, while as likewise the under curing also adversely affects the joint strength due to the incomplete reactions and the reactions which will be occurring during the curing, like vulcanization, polymerization and condensation. So, the common kind of resins which are used for developing the adhesive joints are like epoxies and silicone, and then modified acrylics. So, these are the things as we have said, for uniform spreading of the adhesives, it is important that surface is properly cleaned, so that it wets to the surface, and the proper joint strength is realized. In order to increase the strength of the adhesive joints further, another combination like weld bonding has been attempted, wherein the plates to be joined are kept in overlapping position. So, here the two methods are used. Either first the adhesive is applied, and then the spot weld is made. So, wherever there is adhesive, due to the flow of current, that area adhesive in that area is burned out, and metallic weld nugget is produced. So, it combines the effect of the adhesive joining and the spot welding. So, there are two approaches which are used in, like the first adhesive is applied, then a spot weld is made, thereafter curing is done, and in second one, first the spot is made, then the adhesive is allowed to flow in, and thereafter curing is carried out. This kind of the joint offers very good strength, as well as the fatigue resistance of such kind of joints is found to be much better than the simple spot weld joints, because it distributes the stresses more uniformly across the joint area, which in turn helps in increasing the strength of the joint, strength and the fatigue strength of the joint. Now, we will talk little bit about the weldability or the ease of the welding. So, weldability is defined as the ease of welding of the metal, but under particular conditions, like ease of the welding of a metal for like by a process, for a purpose, and under given fabrication conditions. So, how easily a metal can be welded to produce good quality weld joints by a process for a given purpose under the given fabrication conditions. So, this is basically the relative property, like a metal can be easily welded by a process for a given purpose under a given conditions, but it will be very difficult to weld by maybe say by any other process. So, I will elaborate this little bit for a while to define the ease of welding. Like if aluminum is welded by the gas welding, so it cannot be welded. But if the aluminum is welded by the gas tungsten arc welding, can be easily welded whatever purpose for which it is to be used. So, the process brings in the difference in the ease of welding, that is why we specify the process. And then the purpose, like say mild steel welded using the simple shielded metal arc welding process for the normal room temperature conditions, its weldability is good. But if the same joint is used under the minus 20 degrees centigrade or minus 30 degrees centigrade under the impact conditions, this kind of the joint is very poor, because there is a lot of great loss in the toughness of the joint under the sub-zero temperature conditions. So, it is important that the function for which the joint is to be made, the fabrication conditions means the kind of the procedure to be followed, that is fixed, the conditions in which joint is to be made. If all those are fixed, then probably it will be easy to define the ease of welding for a given metal. For defining the weldability of steels, normally it is somewhat easier, because basically the two aspects are looked into: the way by which heat affected zone of the steel behaves and the kind of cleanliness of the weld which is obtained. So, if the heat affected zone is more problematic in terms of the heat, in terms of the hardening, cracking, embrittlement. So, all these will be leading to the reduced weldability of the weld joint. On the other hand, presence of the pores, inclusions, slag, like solidification, cracking due to the presence of the low melting point things like silicates, etc., all these will also be lowering the weldability of the steel. So, we need to see in which way during the welding a steel behaves with regard to the heat affected zone and the cleanliness of the weld metal. I will talk in detail about the ease of welding of the steels as well as the factors that affect the ease of welding of the steels in the next presentation. Now, here I will summarize this presentation. In this presentation, basically I have talked about the solid liquid joining process as well as chemical joining process like adhesive joining. So, the principle of the brazing, principle of soldering, and the fundamentals of the adhesive joining have been highlighted in today's presentation, as well as the conditions under which this kind of the joints are applicable. Thank you for your attention.